there's a lot of S's in this unit. Right? A lot of S words. So we have a list of numbers here. A sub 1, comma, A sub 2, comma, A sub 3. That A sub 1, A sub 2, A sub 3, that just stands for a number. And we'll see examples of this in a minute. But if I have a list of numbers, that is called a sequence. Alright, so a sequence, I'm going to skip to that bottom bullet point in that little section here. A sequence is a list of numbers. And the list of numbers follows some kind of pattern. So today our pattern is going to be adding or subtracting something. So you could multiply, you could do all kinds of different things. Next, if I have that same list of numbers, but I put a plus sign in the middle, so I add them up, that is called a series of n terms. So we have sequence and series. Now if I have the sum, another S word, S sub n is called the sum of the series. So we're going to be adding things up. We're going to be writing out patterns. We're going to be finding missing terms, all kinds of things. But the difference here is that a sequence is a list of numbers. A series is when you add up the list of numbers. So that's the difference. A sequence is the list of numbers. The series adds them up. Now we have a couple characters, two columns underneath on your paper. And we're not going to go do all of it on each column, but at least some examples here. So an arithmetic sequence, we're on the left, is an ordered list of numbers in which the difference between each number is the same. So for example here, if I gave you the pattern 4 plus 9 plus 14 plus 19 plus 24. Oh, why am I doing pluses? Sorry. I don't know. Erase the pluses, make it commas. Make them commas, I'm sorry. 4, 9, 14, 19, 24, comma, dot, dot, dot. What are you adding each time? What's the pattern? Not 10. 5. So you are adding 5 here each time. That is your pattern. Okay, so an arithmetic sequence adds the same number every time. A non-example, so a sequence, because remember, a sequence in general is just a list of numbers, but one that's not arithmetic would be something like this. If you have 1, 1, 2, 3, 5, 8, 13, dot, dot, dot. That's actually a really famous sequence. It's called the Fibonacci sequence. You heard of the Fibonacci? Makes like the spirals and the golden ratio. That's called the Fibonacci sequence. It's a cool sequence. It's really cool, but it's not arithmetic because I'm not adding the same number every time. Here to get from 1 to 1, I add 0. 1 to 2, I add 1. So that's already not the same pattern. Now, when I have a formula, or we already have a formula here, and you do not ever have to memorize these formulas. You just need to know how they work and what the parts do. So I have a sequence. Again, A sub 1, A sub 2, A sub 3. That just represents the numbers. Each value, each number in the sequence is called a term. So you have a bunch of terms, and the difference between each term is called the common difference. Common because it's always the same. We're going to call the common difference, the letter we're going to use to represent it is going to be D. Okay, so the common difference when we use our formulas is D. That's the number you add over and over. A sub n is a notation you're going to see a lot. A sub n is called the nth term. So what that means is, like, instead of saying like the second term or the 12th term, the n is going to be like a general, this is the term I'm trying to find. All right, we'll see that once we get into some examples. You will see what it is. But the nth term has a formula, and we're going to use this formula a lot. It's a sub n equals a sub 1 plus n minus 1 times d. So really what that means is this: if I ask you to find me the 100th term in a pattern, you're going to use this formula to help you find it. And we're going to do examples on the back. I'm going to actually skip the example on the bottom. All right, so I know we haven't really talked about how this is working yet, but once I talk about series, then we'll put pen to paper and make it happen. Okay? So a series here, again, is the sum. A series is when you add up a list of numbers. So if I have a pattern, like if I have 2 plus 4 plus 6 plus 8 plus 10, and I keep adding them up, that's an arithmetic series because you follow the pattern of adding 2 every time, right? Your common difference would be 2 here. And you're adding them up with a plus sign. So that's a series. A non-example would be something like 1 plus 2 plus 3 plus 4. Because that's not arithmetic. I'm not adding the same number in between each term. You good with that? All right. Now I have a formula for this too. We're going to have a lot of formulas by the time.
Wait, why does the second one not work?
I don't know. You know. I'm acting like it's Friday. It's Monday. I guess I'm just not warmed up yet. 1 plus, let's do this. 1 plus 2 plus 7 plus 9 plus
4.
12. We gotta go 4. There we go. I don't know. That one's not arithmetic. Sorry, guys. I know what I'm talking about. I definitely know what I'm talking about here. Trust me. Just not on that one. Okay. So it doesn't follow a set pattern. Now here's a yucky formula. Another one which really isn't that bad once we start to use it. But this S sub n formula is what you're going to do to find the sum of a bunch of terms. So it's not hard to add up 3 numbers. Like if I just said add up 1, 5, and 9, that's easy to do. But if I say here's a list of 210 numbers, add them up, do you want to type all that in your calculator? I don't. You might want to, but I don't. So that's what this formula is going to be good for. So what does every part of that formula mean? Well, S sub n is what we call the sum of n terms. So the n is going to tell us how many terms you're adding up. That's on the bottom here. The n is the, I'll write it this way, the number of terms. So if I say add up 10 terms, your n is going to be 10. A sub 1 is always the first term. So A sub 1 is our notation for the first number in the pattern. And A sub n is the nth term again. We called it that on the other column. So that's just your notation for you're going to be adding up a bunch of terms. We need to know particular ones. And again, we'll do more examples on the back of your paper once you flip this over and you're ready. No need to add more examples. We're already going to do plenty of examples. All right, so basically all I showed you so far are your formulas and a little bit of vocab about what the parts of the formula do. So at the top of the paper here, I will always give you a box with the formulas. Right? It will always be on pretty much every page you do, but we're going to write them down here first. So our formula to find the terms of a sequence is this. Again, we called it our nth term formula. So the sequence is the A sub n formula, which is A sub n equals A sub 1, that's your first term, plus, I like to write it this way. I like to put the D times n minus 1. Now when we were on the other sheet of paper, like the front, we had A sub n is the first term plus n minus 1 times d. They just had the d on the other side. I like putting the d first, but if you want, you can put the d on the right. It doesn't really matter at all. So that's the first formula we're going to use. We're going to use that one a lot. That's what we're going to start with today. And then we're going to go to the series formula. That's your S sub n, the sum. Right? Sum is your series. And the formula here was that n over 2 times A sub 1 plus A sub n. We're going to do that in a little bit. We're going to start with the top formula, make sure we understand the top one, and then we'll go down to the next one. go through these. I kind of start the problems pretty easy, and they get more challenging, and then the last one's going to be really fun. Promise. It was kind of fun for me to do. We'll see when we get there in about 20 minutes. All right, so we're given a sequence. 1, 5, 9, 13, dot, dot, dot. And the reason we put dot, dot, dot is because sequences can go on forever. So this pattern goes on infinitely. We need to start by figuring out what is the common difference. What number am I adding every time? 4. Okay, so our D, our common difference, is 4. Now we're going to write a formula for the nth term of the sequence. So what that means is we're going to use, when we find the nth term, a sub n. Okay, that's what our formula is going to be. So we're going to start with a sub n here, equals. All right, let's figure out what we have. Do I know a sub 1? That's my first term. Do I know my first term? Do I know the first term? I think I do. It's 1. So I'm going to put a sub n equals 1. Plus. Now remember, I like to put the D first. It doesn't matter. I'm going to put D first because that's what's on your paper. What we just said the common difference was 4. So I'm going to do 4 times. Now I'm just coming up with a formula here. I'm not finding a specific term. So I'm going to put n into that equation. Because what I came up with here is a formula for any term that I want. If I pick any number for n, I can find that by putting n into the equation. This is totally fine, but we actually would like you to simplify that formula, which just means get rid of the parentheses. So we're going to make sure we distribute the 4, collect the like terms, so we have a simplified formula. So we'll have a sub n equals 1 plus 4n minus 4. And then what do you get when you collect those like terms? A sub n equals what?
4n minus 3.
Yep, 4n minus 3. That is our A sub n formula. That is the sequence formula for this pattern. So from that formula, I can find any term that I want. Right now, they want us to find the 11th term. But I could find the 500th term using that if I wanted to. So the 11, that is the n when I use the formulas. The 11 is the term number that I'm looking for. So I'm going to put 11 in for both of the n's here. So I'm going to find a sub 11. What's the 11th term? Well, all I have to do is take 4 times 11 minus 3, which is 41. So if you list it out by hand, 11 numbers in a row of this pattern, the 11th one would be 41. Now that should be pretty easy. Yes? Agree? Good. It will get a little bit more challenging as we go. But we gotta start with the basics. If you like the easy ones, we like lead you into it here. Okay? Right, now the next one, we want to find the 100th term of this pattern. 5, 8, 11, 14, 17, on and on and on. So again, if I'm finding a term, I'm going to use this formula. This is the one that's on the top of your paper. You don't have to write it down again if you don't want to. That's what we're using. So let's figure out what information we already have, because there's actually a lot that we kind of need here. Do I know a sub 1? Do I know the first term of my pattern? Yes, it's 5. Right? Start with 5. Then I need a common difference. Can you guys figure out what D is in this pattern? 3. Okay? And do I know what n is? Do I know what term number I'm trying to find? 100. So I know n is 100. So the nice thing here is I actually know all the information that I need. So I could write the n term formula like I did in the last one. But this problem, since I'm just trying to find a sub 100, I'm just going to take all those values I know, the parameters, put them into the formula, and type it into my calculator. So I will do 5, which is my first term, plus my common difference of 3, times my n of 100, minus 1. And this is where you need your calculator, unless you like multiplying and adding big numbers in your head.
Which I do.
You do. And you're going to love when we get to geometric sequences later. Those numbers get really big and you have to be really fast.
Well, there's not that.
Lots of big numbers. And really small numbers too. Alright, so what is the 100th term in this pattern? What'd you get? 302? Yes? No? That's what a couple people got. Okay. Not alone then. Got 302. So if you wrote out 100 numbers following this pattern, the 100th one would be 302. So far, all we've done is write a formula and find a term. Are we okay with finding terms? That's like the easiest thing you can do with sequences. So let's make it at least a little bit more challenging. I actually like these ones where they fill in the blank. I find them like weirdly enjoyable. I don't know, but I'm a math teacher, so you know, take it out for what it's worth. So we're gonna find the missing term. So I'm giving you in the first one, the first term and the third term. We need to figure out what the second term is. So we're gonna come up. Yeah, but let's find a simple way here. So that was easier than finding these ones a little bit. Like, let's come up with a formula because some people cannot do that in their head. Here's the way I would do it. You could use this a sub n formula down here if you wanted to. But I actually think that's too hard. Like, not too hard, but it's just a little bit too much work to have to find what the common difference is. Because we actually need to figure out the common difference here in order to fill in the blank. So here's my suggestion. Remember, the common difference is the number you add every time. So to get from 9 to this blank, you need to add the common difference, right? One time. And then to get from the blank to the 1, you need to add the common difference again. So I'm going to create a little formula. I'm going to say if I take 9 plus how many common differences? 2 common differences. That gets me to 1. My first year teaching, I did. You could find the average. Yeah. Yeah. So I'm going to subtract 9 here. Yeah, there's a couple ways to do it. I actually used to teach it a different way, but I think this is easier. So I have 2d equals negative 8. So what is your common difference here? Negative 4. So that means you're actually subtracting 4 each time. So if I start at 9 and I subtract 4, Jamie, what did I get?
5.
5. And then you can double check because if I subtract 4 from 5, you get 1. Does that make sense? So it's pretty easy when there's one blank. But the reason I wanted to show you how to find like a formula for it is because when I have a few more blanks, a little harder to do in our head. We could still do it, but it might be a little bit more work. So same kind of thing. Let's figure out the number of common differences you need to add to get from negative 13 to 3. So how many is that? 4. Right, so I'll do negative 13 plus 4 common differences equals negative 3. Alright, so I add 13. I just like these ones. They're so enjoyable. 4d equals 10. Who doesn't like finding common differences? Don't you guys? That's just whatever. This is fun. I like these. Like, I actually really like these problems. So, what's 10? We're going to do long division later this year. But there are going to be a lot of x's involved next quarter. What's 10 divided by 4? 5 over 2, which is 2.5. We'll use 2.5. Because 2.5 is going to be a little easier than fractions when I have to add it to negative 13. What's negative 13 plus 2.5? Negative 10.5. I forgot the 1. Negative 10.5, and then I have to add 2.5 again. Negative 8, and then negative 5.5. So that one, especially because it was a fraction, might have been a little harder to do in your head. Right? Does that make sense? Lots of ways to do this. That's the nice thing about these problems is I'm showing you one way, but there might be other ways you can figure out the values. Okay. Now we have a different one. This one's a little bit more challenging. I know a sub 1 here. So they're giving me the first term of the pattern is 3. The fifth term of the pattern is 19. And then some unknown term of the pattern is 163. And I want to know, what's the term number for 163?
I don't know.
I don't know either. I forget, actually. I've forgotten the last 45 minutes. Yeah, do you know how many numbers are in my head? I teach 3 different classes.
You should have the index of all math ever.
Yeah.
All problems.
I don't think I know all math ever, but I know a lot of math. I know more math than you do.
Yeah, you qualify as a
Did you know? So my favorite statistic is, and this was back earlier 2000s, is that 95% of the math that's in the world today has been created or invented since 1900.
What was that?
95% of the math that is in the world today has been created or invented, however you want to think about it, since 1900. And you know how old the math that we teach in high school is? It's older than from the 1900s. So that's it. The 5% of the math that we have today, that we teach in high school, is like over 100 years. Like,
Well, you knew that math. How did you know this math?
I do know this math. I still have the answer memorized.
What's new math?
New math, very different than this.
Just the alphabet.
It's a lot of zeros. Yeah, there's a bunch of letters.
Yeah, it's just the alphabet.
Yeah, it really. Yeah, I mean that's my background is in theoretical math, and there's like no numbers. It was just letters all the time. Just everything was letters. It was just all like, in case you ever might want to do this to a number, here's how you do it. Yeah, it's fun. Okay, let's figure out how we would find n here. Now again, we are working. We're going to use logarithms in this unit. I bet you can't wait for that. They're going to come back. We have our a sub n formula. We don't know what n is. Let's at least identify the information we do have. We know, let's see, we know a sub n, we do know that. We don't know what n is, but we know a sub n is 163. Okay? We know a sub 1, we need that for our formula. We know a sub 1 is 3. Do we know d? No. So there's a problem. I don't know d, and I don't know n. So in order to ultimately find the n, what n is, I have to figure out what the common difference is. So there's a couple ways to go about this. How do you guys think you might want to find the common difference? We can use the formula or we can use another method. You want to use the formula? Okay. Because we could use the formula or we could do what we were just doing back here. Fill in blanks. You want to do this way? Filling in blanks?
Yeah.
All right, let's fill in blanks.
I do not.
Well, then you can use this a sub n formula.
Yeah.
So let's use the blanks. Let's do it this way, because if I fill in the blanks, we know like a sub 1 is 3, right? So this would be a sub 2, a sub 3, a sub 4, a sub 5. Do you agree with that? It's 19. So we could set this up just like those previous problems to find d, and then, so let's see. If I set this up, I'm going to have 3 plus how many common differences? Plus 4 common differences gets me to 19. Well, if I simplify this, I get 4d equals 16, and what's your common difference? No. 4. Divide, not subtract. Divide. So your common difference is 4. So now I know the first term, I know the common difference, I know what the nth term is. Do I have enough information to use my formula to find what n is now?
Yes.
I do. So now let's use our new favorite formula, a sub n, to find the equation. So I'm just rewriting it there so we can see it. So what should go in for a sub n? 163. So 163 equals my first term of 3 plus my difference of 4 times n minus 1. Now again, there are lots of ways to solve this. You could have found d a different way. Also different ways to solve this equation. I'm going to start by subtracting 3. So I'll subtract 3 and get 160 equals, now here's where some of the differences are. Do you guys want to distribute the 4 or do you want to just divide it away? Distribute, okay. You don't like division? Okay, so we'll distribute and we'll get 160 equals 4n minus 4. And then let's add 4. So 164 equals 4n. And then you divide. So how many terms are you adding up in your list? 41. So 163 was the 41st term in the pattern. Not bad so far? you feel like, at least with what we've done, that you can manipulate these formulas to find different parts of the sequence? Yeah? Okay, let's talk about series. So once you finish writing things down, we're going to flip to the other side. And we're going to do that S sub n formula now. Got a couple. We're building our way up to the really fun problem here in a minute. I know you can't wait. You've been like waiting all class for this. All right, let's find a series. So we're going to review a sequence as we go here. So we have a sequence, 2, 10, 18, 26, dot, 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 that pattern continues. I still need to find the common difference. What is the common difference for this sequence? 8. All right, so you add 8 every time. Now we're still going to start by finding the nth term, right? So again, that means you need to find a sub n equals. We need an equation for the nth term of a sequence. So that starts with this formula on the right, a sub 1. What is my first term? 2 plus, we said our common difference was 8 times n minus 1. But again, I don't typically want to leave that formula. If I tell you to write a formula, I want to simplify it as much as possible. So I'm going to distribute the 8 here. And that'll give me 2 plus 8n minus 8. So what is the actual formula when you simplify it?
Question.
8n minus 6. You guys okay with that? Hope so. All we did was distribute and collect like terms.
Yeah, I'm good.
Okay. Well, that formula is what we use to find any term we want. For this problem, we want the 15th term, but I'm going to ask you to find like the 272nd term, and you can use the formula. So let's take 15. Again, that's our n. The number that we're looking for is what goes in for n here. So I'm going to find a sub 15 equals 8 times 15 minus 6. So when you have your formula, it's pretty easy to go into your calculator and simplify. So can someone tell me what is the 15th number in order of this pattern? What do you got, Anna? 114. Good. Okay. So I know the 15th number, but here's where we are going. We don't want just the 15th number. I want to know the sum of the first 15th number. So what that means is if you took 2 plus 10 plus 18 plus 26 plus 34 plus up to 114. What does that equal? Well, 15 numbers isn't that many. You could type them into your calculator, but it's still kind of annoying. So let's use the formula. S sub n. So when I write this down, I have S for sum of n is the number of terms we're adding up. We're adding up 15 numbers. So I have S sub 15 equals. Well, the formula is n over 2. So again, my n is 15 over 2. And in the parentheses, I put a sub 1, which is my first term, 2. And then a sub n. We already found a sub n. That was 114. And you're going to take your calculator. Make sure you can type that in correctly to get the sum. You can type it in like that. You can simplify 15 over 2 to be 7.5. I don't care, as long as you get the right thing. So check and see what you get as the sum here. Make sure you can type it in.
Okay.
What did you get, Bobby?
Got it.
That is right.
Got
Did
it.
anyone not get 870? No?
Questions.
You okay so far? Alright, now let's switch it up. We have 2 more we're going to do. We okay with this one?
Yes.
Okay, that's just a straight find the sum. What if I now say find the sum, so I'm still using that S sub n formula, of the series 26 plus 29 plus 32 plus up to 212. Let's see what we need. I need to find the sum, so my goal is to find S sub n. Do I know n? Do I know how many numbers I'm adding up? Now, that's kind of the problem. I don't know n. That's what I need to find first before I can find the sum. Because I do know a sub 1, right? I know the first term. What's the first term? 26. And I know the nth term. I know a sub n is 212. I just don't know what n is. I don't know how many numbers I'm adding up. So, what do I have to use to find the n? Can I use the S sub n formula? No, I have to use the A sub n. So I need to put stuff into that A sub n formula, find n, and then I can find the sum. So what should go in for A sub n? What do I say that that is equal to? Finding n here. Remember, A sub n is 212. So I'm going to take 212 equals A sub 1, which is 26, plus, do I know the common difference? What's d in this formula? What do I add every time? 3. So I'm going to do plus 3 times n minus 1. So we've found n before. Let's simplify, let's subtract, let's distribute, and do that. So let's see, what's 212 minus 26? Is it 186? Yeah? Equals 3n minus 3. So I'm going to add 3 here. 189 equals 3n. And what is n? What do you get, Bobby? 63. All right. So it turns out we are adding up 63 numbers in this list. Well, now, that's why we put the dot, 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 so we don't have to type them all out. But now I know n. So I have enough information to go back to this sum formula and actually find if I added up all 63 of those numbers, what would I get? So let's do that. We're going to find the sum of those 63 numbers, S sub 63. So my n here we just found was 63. So I'm going to put 63 in for n. So I have 63 over 2 times the first term, 26, plus my last term, 212. And you're going to carefully type that into your calculator, and you should get a 4-digit number. I'll tell you that. It's in the thousands. Tell me what you get. Yes, Anna. Or, here is he, not Anna. Anna's over there.
I got 7,409.
Yes. 7,497. So make sure you get that if you type that into your calculator. Good? Are you ready for the most fun problem all day? No? Oh. Too bad. It's happening. Alright, we're going to actually skip part A here. We're going to go to part B. I'm going to tell you that if you're someone that writes really large, I want you to write a little bit smaller. I know, you know it's bad when I tell you to write smaller. We're not doing A, so if you need to bleed some of your work, I'm going to do my work starting over here because I'm on the board. I have to write bigger. But it'll be a little bit of work, but I'm going to do some of it for you. I'm going to save you a little bit here. So we have this pattern. -7 plus -4 plus -1, on and on. And I want to tell you that the sum of a bunch of numbers in this pattern is 210. We want to know how many numbers n did we add up to get the sum of 210. So we're talking about a sum here. So in this sum, we need n, right? That's in our formula. We don't know what n is, so that's what we're trying to find. Do I know a sub 1? Do I at least know the first term in this pattern? Yeah, I know it's -7. Do I know a sub n? Do I know the nth term, the last term I added up? No, that's the problem. I don't know what a sub n is. I don't know what that number is. So before I can find n, I at least need to figure out what am I going to put into this formula for a sub n. Now this time I'm actually going to tell you we're not going to find a number. We're not going to figure out what the term here is, but we are going to figure out a way to represent a sub n. You will probably have to do at least one or two more of these, but they won't all be this crazy. Let's see. So let's use our a sub n formula. Okay? Let's use this guy right here. Okay. A sub 1, I know. I do know a sub 1 is negative 7. Plus, I can find my d for my formula, my common difference. What's the common difference here? 3. Okay, so I have plus 3, and we don't know what n is, so I'm just going to do plus times n minus 1. Well, let's at least simplify that, because I think that'll get us off to a good start. So I'll have a sub n equals negative 7 plus 3n minus 3. What does that simplify to be? 3n minus 10. Right, well, that's what a sub n equals. That's what we're going to say a sub n is, 3n minus 10. Now, that still doesn't really help us because I don't know what n is, but it helps us more than you think it does. Because I'm going to actually use that a sub n, that 3n minus 10, in my formula up here. So bear with me. Just write down what I have. It'll come to the part where I'm going to do a lot of work for you in just a second. What goes in for s sub n? 210. So I'm going to take 210 equals. Now again, I don't know what n is, so I'm just going to leave n alone and say, well, I have n over 2 times, what's a sub 1? Negative 7 plus my a sub n over here, which is 3n minus 10. Okay, so at least still an a sub n. What does inside the parentheses simplify to be? 3n minus 17. So I have 210 equals n over 2 times 3n minus 17. Are you okay with that so far? What should I do next? What about? What should I do with the 2, maybe? Let's multiply both sides by 2. Let's make the 2 go away, so I'm done with my fraction. Okay. I'm going to have 420 equals n times 3n minus 17. Oh, this is still not looking fun. What do you think? What's next? Distribute. Okay, let's distribute. So I'm going to take the n and distribute it on the right side. So I have 420. I don't know if you know where this is going. But I'll get 3n squared minus 17n. We're going to end up factoring, but I'm going to do the factoring for you.
We love factoring.
Oh, you should. You're factor masters. So you need to subtract 420 from both sides. Oh, and factoring is going to come back next unit. You're never going to escape it.
Yes.
I'm going to subtract 420 and get 0 equals 3n squared minus 17n minus 420. And usually I would make you factor that with me. But we're running out of time. So I know you're really sad, but let's pretend we did what factoring method here? Split the middle. If I did split the middle, I would get this to factor. Let's see if I remember. 3n plus 28. Yes, I memorized that one, Bobby.
I'm proud of you.
That's my factored form. Oh, but wait, how does that help me find n? You said each one equal to 0. Okay, wait a minute. If I set this one equal to 0, what would my n be? 15, that's your answer. Do the back. For your homework, real quick, there's only 5 columns on the back. The answer's on the bottom, the key's on canvas. I want you to do the back one before we start with what we're going to do. Sorry, we couldn't finish that one. I know your heart's going to be broken.